welcome to geometry. So this is Tuesday's lesson. Open your books to 78. So this is in continuation of rotation. You always rotate it from a certain point. Here we have rotating from the origin, and we have rotating from a certain point. And all of these have their certain formulas. If we look up here, if you're rotating from the origin, that means 0, 0, right at the center. You have a translation or a rotation of 90 degrees, so it's moving one direction. You're going to use this coordinate, 180. You're going to use these, 270. You're going to use those. So you have that on your book. You can zoom in if you need to, but they're all on your book. They're on page 511. Here, example 1, I summarized them, made them smaller. I just don't like writing on the board that much. Here says you have these 3 points. It looks like there's 3 vertices. It's a triangle. You rotate it by 180 degrees by the origin. So each of these points, you're rotating 180 degrees. So that means you're completely going from forward to backwards. And to do that, you follow this over here. So you make x and y a negative coordinate. So that means we have this. We have our new ones. Whenever you're putting new ones, you put n, comma, whatever you have. N, comma, whatever you have. P, comma, whatever you have. Because each of those commas signifies that it's been translated, it's been rotated, etc., etc. Here, according to this formula, for it to rotate 180 degrees, you have to make your coordinates negative. You're not switching them at all, you're just making them all negative. So 1, 1, it's going to be negative 1, 1. Or negative 1, negative 1. 4, 3, negative 4, negative 3. 5, 2, negative 5, and negative 2. And this is what your answer will be. You're not going to graph it, but I'm going to graph it just to show you how it's going to look. So I have my graph here, very tiny. So my new vertex is m, negative 1, negative 1. So that's m here. And negative 4, 3, or negative 3. It's going to be here. And p is negative 5, 2. P. And I have a triangle like this, so you can tell it's been rotated this way. It also tells us it's counterclockwise. When you think of a clock, it's always working this way. So I have that clock up there. It's always working, it's always working its way around. So over there. Now, looking over here, counterclockwise just simply means the opposite direction. So if my clock is moving this way, counterclockwise meaning it's moving backwards. So here it went from this point and it's moving its way backwards. So that's very important to know. The next type of rotation is when it's not in the origin. Those only work if it's in the origin. Man, I gotta move this up. So only if it's in the origin. So you're gonna get coordinates that are not in the origin. Here, if it's rotated by 180, and this only applies to the 180, you use this translation. So it rotates 180 from the center AB. So it could be a new set of coordinates. Your new translation, your new conversion would be 2 times your center point of x minus your actual x, comma 2b minus y. So AB is your center point, and your x and y is your coordinate somewhere else. Example 2. So we have these 2 set of coordinates, and they want us to rotate it 90 degrees counterclockwise. Here we cannot apply this method up here. For this, we literally have to see the distance, and we have to actually do our own math. So if you need graph paper, just grab some from the side. But here I have these coordinates. So we're starting with negative 3 and 4. I'm going to label this as number 1 here. They want us to turn this, they want us to rotate it counterclockwise from 3, negative 6, and that's from this point here. So from here, they want us to rotate it counterclockwise. So a clock is working its way this way, right? So that means clockwise, if I want to rotate it again, I will move it this way. But I'm doing counterclockwise, so I'm working the opposite direction. So now I'm moving this way. So I want to move this from here to here, but I'm rotating it around. Think of like a center, and you have string, and you're working your way around it. So you're trying to work your way around from the center. So here we have the center point. We're trying to work our way from 1 around the center, but counterclockwise, so it's going to move in this direction. To do that, it's actually very simple. You count the number of units. So if I had this here, so this is from my point, this is my center right here. So from this point, 3, negative 4, I'm going to count the number of distance between those 2 here. And you can do distance formula, but the best way is just counting. It's 2 units away. If it's 2 units away, from the center point, that means it's going to be 2 units everywhere. I'm going to count 2 units this way. So let's see, this is my 1 box, my 2 box. So 2 units to the left and 2 units up. And this will be my new point. So I'm counting 2 units left and up. The reason why I'm working this way is because it's counterclockwise. So 2 units to the left, 2 units up, and therefore my new point here is this right here. And this will be -1, 6. So that's how they would get all those points there, is from rotating it at a time, and then you get those set of coordinates, and you get that. So if it asks you for rotating at 9 degrees, you're just counting the number of units, how far it is, and depending if it's counterclockwise or clockwise, you're counting it for that. But again, think of a string, you put it down the middle, and you're moving the string all the way around, so like a radius of a circle. So when you move it, it's going to create a rotation from here to there. So your answer is -1, 6. That's the new coordinate. Next one is you're rotating this point at 180 degrees from the center of -2 and 3. So this is where we're actually going to use the formula here. To understand what to use, your center is always A and B. So I'm going to put -2, 3. I'll put on top A, B. And then X and Y is the coordinate that they want you to rotate from. So that's 7, 8. This is X and this is Y. Now to use a translation, you simply just plug it in. So it's 2 times A. 2 times A is -2 minus your X. Your X is that coordinate that you're rotating, which is -7. That's your X coordinate. Now your Y, it's 2 times your B. B is your center point. Your center point here for Y is 3 minus Y, so it's that coordinate you're rotating from, and that is 8. So this is your X coordinate, this is your Y coordinate. To solve this step by step, I get -4 minus 7, comma, 6 minus 8. Let's keep on solving. -4 minus 7 is -11, 6 minus 8, -2, and that is your rotation. And they don't have a picture there, but all you need is a new set of coordinates there. So 9 degrees, you're counting the units, and depending on what direction you're moving from, you're going to count left to right, so it's going to be like X, Y. 2 units X, 2 units Y. Example 3, this is where it's slightly different. Here we're looking at Ferris rule. Find the angle of rotation from M to M comma. So I went from M to M comma. Now we're dealing with circles. One thing we know about circles is the sum of the angles inside a circle is equal to 360. So like the sum of the angles inside a triangle is 180. Here, it's equal to 360. We are trying to find, I'm gonna mess up my marker, the distance here to here. We're trying to find that angle there. So that's what they mean by the angle of rotation. To find that angle, we have to divide 360, because that's the sum of the angles, by the number of sections that there are. In the book, they use sections by the Ferris wheel. Each cart is a section. And if you count the number of carts around that circle, I didn't draw it, but there is about 20 of the carts. So each section has a little cart in each one. Now, if we do 360 divided by 20, we get 18 degrees. That means each little cart from one cart to the other is 18 degrees. But again, they're not asking for the cart, they're asking from the measurement from the angle of M to the new rotation of M comma. To do that, we have 18 degrees. We know each of these boxes are 18 degrees. Now we have to see how much boxes there are in between. So from this one to this one, it's 1, 2, 3, 4, 5, 6, and there is actually 7. If you look on your book and you count it, there are 7 carts from the center. So I'm going to multiply 18 by 7 because each one is 18 degrees. I can do 18 plus 18 plus blah, blah, blah. It's easier just to multiply the two. When you multiply them, you get 126 degrees. So that means from M to the new rotated version of M, you end up with 126 degrees. And let's see if that's right. Yep, that's right. So that's all you would do. If you have any questions, make sure to let me know down there. Have a good day.